I again welcome all of you. So in this particular session we will have two parts. So initially this is a small introduction to the field and all. This should be maybe 20 minutes, half an hour. I will give you overview, some context, what we are talking about. And after that comes the more interesting part, which I think all of you are more excited about, in which we will make you visit the microelectronics lab in KR. And then we will give you demo. My students are there. They will give you demo of some very nice fabrication tools that help you fabricate nanoelectronics, microelectronic devices. Okay. So during the complete session, feel free to ask any question. And whenever I want it to be interactive. So if I ask some question, just reply, answer it. Even if it's wrong, don't worry.
Sure.
Later, when you go during the demo, also right, please ask question to the PhD students, right, when they show you the machine. Okay, be curious. So the title of the talk, as you can see, it's from SAN to microprocessor, right? So we will see during this few slides how from a very simple thing like SAN, we get a very beautiful thing like microprocessor, which runs, I think, more or less everything that we see nowadays. So this is how the early modern human look, right? When I say early modern human means this human, right, which existed around 2 lakh to 3 lakh years ago, right? This is how they look. Okay, so physically they were more or less like us. So for the till 12,000 years ago, they lived more or less the same life. So for around 200 to 300,000 years, right? They lived more or less the same life. They used to hunt, or they used to gather fruits and all that. There was not much. Most of the time they were either busy and they were mostly in the survival mode. Okay, always they have to worry about the next meal, okay, or they have to worry about the next disease. So the life expectancy was very less. There was not many invention during this time. Okay, mostly they invented is what, as you can see in the hand of this guy, there is a tools and all they invented. So they could hunt more, but that was the extent of their invention. So for these like 100k years, right, 100 to 200k years, they lived more or less, same life. So if someone was born, let's say 200k years ago, and someone was born, let's say 100k years back, they won't see much difference in the lifestyle. Okay. But one big invention or discovery, I should say, it happened around 12,000 to 15,000 years back. Can anybody guess what it was?
Wheel.
Fire.
No, not fire.
No.
Fire, I think, was invented even before this.
Wheel.
Stone tools. No. I mean, stone tools were there even before. As you can see, like this guy has some kind of tool. But this is not like a phenomenal discovery. Stone tools, it is a good discovery, but it cannot change the course of human. Any other guess? So that discovery or invention is basically agriculture. Okay. So what agriculture did is basically it gave us lot of time. Now the humankind, they started coming out of the survival mode. Okay. So you can, in agriculture, what happens? You grow some crops, then you have a very big stock for many months, and then you grow for one or do some work for a couple of months, and for the rest of the months you are free, you have stock. So you have very good amount of time you can spend on writing poetry, doing drawing, or inventing something else. So that's what happened after the discovery of agriculture. So before discovery, the groups of humankind were like 30 people, 40 people, 100 people, not more than that. But after the agriculture, what happened? Many civilizations started to come all around the world. For example, of course, in India we had many civilizations, Mauryan, and in South India, Chola. Then we have Egyptian civilization, Roman Empire, and all those things. Okay. So then big society started to form. Okay. So agriculture is one of that big discovery which changed the course of our human life. So civilization started to come, but then there was also fighting and all. Okay. But of course, at the same time, people started building big buildings, temples, and all these kind of things. Why? Because they had spare time due to agriculture. They started settling at one places. But again, for these 12,000 years ago, if you are born here or you're born here, you will see some difference, but not like a drastic difference. Okay. But of course, agriculture changed a lot. Then something else happened around 300 to 400 years ago. What is that?
300 years ago.
400 approximately.
The Aristotle born and he gave the science to the whole world.
That's right. So before this, Aristotle actually he was born 2000 years ago, but around that time, okay, 2000 to I should say 500 years ago, the outlook of human beings, as society, especially it started in the West, it started to change. They started to have some scientific thinking. Okay, so science took over, the way we think and the way things are implemented, and this resulted in something which we broadly know as industrial revolution. So this is the next big thing that happened in the life of mankind. And what is the product of industrial engineering? Then we have all this fancy machinery. So industrial engineering, industrial revolution, right? It again gave us a lot of time in hand. Okay, agriculture gave some more time, then industrial, it again expanded. One difference between this age and this age is, so all these luxurious things we see, right, in this Middle Ages we call, these were limited to, let's say, the kings or the rich people. What industrial age did this, they gave luxury to the common man. Okay, that is very important. So now everyone could have nice clothes, and in fact now many people can drive 2-wheelers, 4-wheelers, things like that, all thanks to industrial age. What industrial age did was basically, machines were introduced, electricity came in, so things were able to mass produce at a cheap rate, all these things happened. So again, this thing continued since last 300 years, and I think this is a very accelerated pace. Okay, so you can see from here to here it took 12,000 years. From here to here it took, here it took 100,000 years. Here it took 12,000 years. And from here to here, this is a very fast change. So if someone was born, let's say 300 years ago, or someone born in 1900, he or she will see a massive difference in the way you will not recognize what is happening. Then finally, 60-70 years ago, one more discovery, one more invention movement. What is that? Computer.
Charge cabinet discovered.
Computer is one thing, but the discovery that underlines it is basically the semiconductor solution. Okay, the semiconductor was discovered, and it is actually, you can say it is a dark horse. So normally we say what is the big discovery, like the answer, people say computer. But the thing that is powering this computer is actually semiconductors. Okay, and all the things associated. So semiconductors, they not only power computers, but they power many things around us. Of course, computers are there, then solar cell, all the display that you see, this projector you see, okay, the AC you see, each and everything has some or the other use of semiconductor. Okay, a small brain is there in all these devices we see around us. And this is roughly known as the age we are living in, right? 20-30 years, from the 1970s till here. We also know it as the age of information technology. So what changed between this and age? So computer increased the way we communicate with each other. That's one thing. So it made our network. Agriculture, it basically expanded the society from, let's say, 50-100 to 100,000 people. Industrial revolution, people started, trading with each other. With computer now, the whole world is kind of interconnected. We start communicating from each other. Okay, so I don't have to explain it, how it has changed. So how this semiconductor, basically it comes from the raw material of the semiconductor. What is this? No, but what is this?
Sand.
This is just sand, right? Very simple thing. You see it on beaches, you see it in desert. Okay, and it's sand is what makes up the buildings and all, right? And what is extracted from sand?
Silicon.
Silica. Okay, so this is the simple thing, and this justifies the title of the talk. Okay, so it is the simple raw material sand. So this sand is converted into something known as microchip. Microchip is one thing. Microchip can be of any form. It can be either microprocessor, or it can be a memory, or it can be some small IC doing the small function. Okay, it's a general term, microchip. Okay. And how does this microchip looks inside? So if I zoom in, right, with a very powerful microscope, it looks something like this. Okay. So this silicon, we make a silicon wafer that sits at the bottom. So this is the silicon wafer. Okay. And all these things you see, they are like metal lines. Okay. So you must have seen this circuit, right, in our house. How are they connected? Let's say this AC is there. So you can see a wire is running down there. It's going in that plug. Okay, and inside of AC also there are various wires. So this silicon chip is also something like that. On a very plain surface, we make various components, basically transistors or diode, or it can be resistor also. And then you have to connect them with each other. So for connection, we use this thing. Okay, this brown thing you see is metal wire, and this blue thing is just like a spacer layer, some insulator. Because what will happen if this is connected?
Oh, short circuit.
Short circuit will happen, right? So we want some insulator between them. So they are connected in various layers, like 10 layers are there, or maybe more. Why there are so many layers? Why we cannot connect in one layer?
To create more potential. So parallel, to make parallel connections.
So reason is, let's say you have many components here, right? You want to interconnect only in one layer. What will happen? Let's say I am connecting this to this. Now I am connecting this to this. So the wire is going to short, right?
Yes,
sir.
So that's why you have to go in 3 dimension and connect like this. Okay. So this is just how silicon chips look. Okay. Silicon, or it can be some other semiconductor. But when you zoom in, so main devices sit at the bottom, and these are just interconnection. And then they are taken outside and connected to the various components. So what exactly is semiconductor? So you guys, I think you are in class 11, 12, right?
Yes,
So
sir.
you must be more or less aware what semiconductor is, right? So normally we have something known as metal. Metal, what is the property? They are very conducting. Okay, their resistance is very less. If you apply some voltage, you can give ideally infinite current. Resistance is almost ideally zero. On the other end of the spectrum, what do you have? Insulators. Insulator, you can apply even 1000 volt, 2000 volt, you will not have any current. Something in between is known as semiconductor. Semiconductor will conduct to some extent, but they can behave like insulator also, they can behave like metal also, depending on something known as the band gap.
Band.
Okay. So the good property about semiconductor is, see in metal if you see, they are already conducting. So many electrons are there.
Yes.
So you cannot change its property much. Okay, whatever you do. Something which is already conducting, you cannot make it, non-conducting suddenly. Similarly here, something which is such a large band gap, you cannot make it a conductor easily. But this is like a sweet spot, right? Here by modulating, let's say, by applying some electric field or by changing the doping, you can either make it conducting or you can make it insulating. So that modulation is there. So we are having control over this. So we can design things using this semiconductor. That is one of the principles. So if I want to compare, right, so the semiconductor is like a, we have like a switch. What does a switch do? Like let's say this switch is there.
Complete the
Breaks
conductor.
or conductor.
Control the circuit that
Supply can open the
or
circuit.
closed.
Right. So that is, of course, that's what the switch does. It makes the circuit close, open.
Yes,
But
sir.
what actually it is doing, it's transferring some information. Okay.
Yes, sir.
If you assume like a switch is open, so some information is there on one end, but when you close that switch, that information is transferred. And what is that information in when we talk about switch? Let's say the voltage or current. That is the information, right? So that is transferred. So similarly, semiconductor can be are used to make transistor, which are like the switch in a microchip. So this transistor, when you make using semiconductor, they can be used to transfer information, right? So for example, when they are in insulating state, right, this semiconductor, they are off. When you change it into conducting state, they are on. And this thing you can modulate using electric pulse, let's say. Okay, so they are transferring information by behaving like a switch. So this is the concept. Now, can anybody guess what this is?
Aeroplane.
No.
That is aeroplane, right?
पहली वही.
Okay, this is aeroplane, but what is this?
First.
Storage, yeah, somebody.
Hard drive.
Right? That's a hard drive. And can you, anybody guess the capacity? This photo is from late 1950s.
1 MB or 3 MB KBs or MB 1 MB.
It is 5 MB.
5 MB.
Okay, but you just see the size of this, right? As big as the aeroplane. And I think this PPT that I'm showing, this is already maybe 8-9 MB. So even this artist cannot take this particular PPT. And has anybody used this? I have used, I think this
Yes,
is
sir.
all
Yes,
must
sir.
be.
Yes,
So
sir.
you guys have used,
Yes, sir.
Not exactly used.
but you have seen, right?
Yes,
What
yes,
is
sir.
it?
Floppy.
It's a floppy drive, right? So it's, I think those who have used it, they know how problematic it is.
Yes,
Yes,
sir.
sir.
And this can only store 1.4
1.4
MB.
MB.
So when I was in school for school project, we used to use this to take the printouts from the printout shop. Okay. So this was in the 1960s, let's say. This is maybe 20 years back. And where do we stand now? This is like, for example, a Samsung SSD. How much can it store? Like 2 TB.
2 terabytes.
2 terabytes. So around 10 to the power 6 times more than this. Of course, the volume is almost more or less same. Of course, weight is more, but you can see the difference. How we have come so far. Okay, in this semiconductor revolution. Another thing that has changed is the clock frequency. What is clock frequency? When we buy computer, right? We look at something known as the what is the speed of the computer. Even when you buy mobile phone, right? You see how fast is the chip set in the mobile phone in gigahertz term, right? So right now it is stagnant at gigahertz, 2.5 to 3 gigahertz. But when we started, right, we say it was around 10 megahertz. So it was around, we can say, 1,000 times slower. And during the last 20-30 years, it kept on increasing. Okay. So what does the clock frequency, how does it relate to the performance? It's direct, more or less directly related. More is the clock frequency means you are able to transfer some information
More
faster,
faster
right?
and easily.
For example, I have to keep something from here to there, right? So if I run at a fast rate, I can keep more things.
Keep more.
If I run at a slow rate, I can keep less things. So that's how clock frequency is related to the performance. So this clock frequency is also kept on increasing last many decades. Okay. So clock frequency is increasing. We saw that capacity is also increasing. So everything related to this semiconductor technology, electronics, right? That is improving at a exponential pace last 30-40 years. And what has all this resulted in? As a consumer, what has it resulted in? Things have become
Faster.
faster is okay.
Faster, cheaper.
Cheaper, that's
Cheaper.
the main.
Yes, sir.
Efficient. For example, let's say if you wanted to buy this 5 MB at this time, that time it will cost you a fortune. But now here anybody can buy this. You know, everyone has those SD cards and all.
Yes.
100, 200 rupees even you can buy 10 times this. So all this progress, right? It has made everything cheaper. And like we saw, right, in industrial revolution, things everyone can afford because of industrial revolution. So now because of this IT revolution, everyone can afford, has access to lot of information technology and communication media. And how has this progress been brought about? Okay, so inside all this thing, one of the major component is transistor. Of course, there are many other components. Okay, but transistor is one of the main component which does the switching and all. Okay. Okay. And how this progress has been brought about? This component transistor, right? The size of the transistor is also decreasing.
Yes.
So all these semiconductor devices can consist of transistor, or it can consist of diode, some kind of devices, okay, using NPN junction. Its size is also drastically reduced in last 30-40 years. For example, in 1970, right, if you see, so the size was around 10 micron, right? So 10 micron is how much here? Around the size of
RVC.
RVC. Okay, so they started actually even very small. But since then, see, it has decreased every year. For example, in the 2010, if you see, the size is around 22 nanometer. So 22 nanometer is basically the size of virus, even less than a. So you cannot see these things with naked eye. So that's how the drastic and exponential the progress has been in this field. Because the size is reduced, what is the implication of reduced size?
We can put more transistors in
Right.
a small space.
In same amount
Right.
of space, you can put more number of transistors. For example, in 1970 when the first processor came out, the number of transistors was only 1000. Okay. Then there is a person who was one of the founder of Intel, Gordon Moore. He gave kind of a law. that after every 18 months or 2 years, the number of transistors will double. And that's what actually happened till now. And if you see, let's say by 2020, the number of transistors is that huge number. Okay. I don't know, maybe I think that is 50 billion or something.
50 billion.
50
50 billion, yes.
So that's the number of transistor counts. And in the same space. So what is the implication of putting so many transistors in same space?
More efficiency.
Sorry?
More efficiency.
Basically more things you can do. Okay. If there are 5 people in the room, they can do something small. But if there are 10 people, they can maybe do something. There is more information exchange, right? For example, in biology also you see that smaller organisms, they have small brains. It's like that they have few neurons connected to each other. But as the organism size grows, there are more neurons connected to each other. So they can do even more complicated tasks. So if you pack more transistors in the same area, basically you can do more efficient work, high computational work, even you can process some graphics and all. Okay, and at the same time, at the same price you can do. So this is the revolution. And how it has been brought about? It has been brought about in lab, something like this, done in industrial complexes, done in research lab, etc. Basically, what is this? Anybody knows what this is? This room is called. There is a special term for this room.
Lab.
Wrapping.
It's called a clean room. So this clean room, right? Basically, it is it first of all consists dry air, and then it has to be very clean, and it is there are various categories like 1,000 something or 10,000 clean room. Basically, the number of particles less than maybe 1 micron or 1 in 1,000. So it's a 1,000 class clean room. Then we have 10,000. That means the number of particles less than 1 micron is 1 in 10,000. So it's even more clean. Okay. So in this clean room, of course, it's a collaboration between many industries. They are making various machines to make this microchips so that we can keep on reducing the size of the transistor. That's the main goal. So if you keep on reducing the size of the transistor, you can pack more transistor in the same area. You can increase the speed. You can reduce the cost, and then you can, using those chips, you can make many other things possible.